Well, hello there. You join me here in the ship's control room. This is where we do everything on board this ship here. And I'm just going to show you the mimic panel that you may have seen on the Dali. It'll be a very similar, if it won't be exactly the same. No ships are ever the same. You can have dozens of ships come out of the same yard and they're all different inside. You may have the same control equipment and the configuration will be completely different. So anyway, I'm going to show you the mimic panel of a typical ship that's a few years old. So here we go. Right, here we go. This is the main mimic panel for the switchboard. Up here we've got this line here. This is where all the generators come up to this line and provide this line with its power. That is 660 volts along there. It's slightly reduced because we've got some load on the main engines here, the main motors. So we have two electric motors on one shaft. So at the moment, all the power is coming up to this line here, and everything's fed from that line. So we might have one electric motor here. This is motor number 2. This is the stern thruster. This is motor number 1. This is the bow thruster. This line here is a transformer that brings the 660 down to 415 volts. Same as here, we've got another transformer there. This is 660 to 415 volts. And we've got another one there which supplies the deck machinery. So this now provides 415 volts along here. Comes down to a transformer that gives us 240 volts for one side of the ship, 240 volts for the other side of the ship. And down here, what we got here is, this is the emergency generator switchboard, which is 415. It's back fed, or should I say it is fed from this line here, which provides all the power to the transformers for the 240 volts and more transformers for another set of 2 transformers. So this is the emergency power line along here. At the moment it's being fed from the main plant via a transformer, but in the event of a blackout, the emergency generator starts and will provide us with 415 volts along this thing, comes through a transformer to give us 240 volts. So that provides all our 240 volt transformer. We have a secondary transformer, which is a backup transformer, just in case the first one fails. So it also backfeeds this way, back up through the emergency switchboard, and supplies us with 415 to the rest of the ship, which isn't enough really to power the main engines, the main motors, but it will provide enough power for the emergency steering, lighting, some of the most basic functions of the engine room, like cooling water, so that we can get the main engines going again. And it will also supply air to the engine room, as well as lighting. Of course, we've got the emergency air compressor that comes off the emergency switchboard. It's just a standard air compressor, but it's because it comes off the emergency switchboard, sometimes referred to as the emergency air compressor. Anyway, I've rambled on. It's rather complicated, and I'm pretty sure other people have done it better than I've done. But anyway, so that's it. That's our main switchboard. And if I just go over to here, we'll just look at the main. This is the main engine mimic, and of course we've got dozens of alarms on this thing. So if a generator does start to flag, as it were, we can actually do something before it trips, because we've got high temperature alarms and then we've got the trip, and you get a few minutes grace between the alarm going off. Of course, on standby we will be monitoring these temperatures anyway, which is part of our job, is to monitor the equipment. Yeah, like I said, it's rather complicated. Now, what happened on the Dali, I do believe, the more and more I think about it, the more and more I'm convinced that because they had bad fuel, the generators didn't stop. They just tripped off the switchboard, but they didn't stop. They continued to run because there was no longer the demand for the fuel. They were able to run at zero load. And of course, if you load up the generators, you need more fuel. And that's what I think happened, is that the generators were running. When the duty engineer came back down to the engine room, he saw the engines were running and put them back onto the switchboard. That is how they were able to restart the main engine so quickly without having the emergency generator on. Now, if you do get the emergency generator back on, it will normally, you would break the switchboard into two parts. The 415 and the 660 would split that switchboard so that the emergency generator will provide the lower voltage and the main set will provide the main plant, which will get the main engine running, which I think happened in that case. Was the emergency generator may have kicked in, but the duty engineer didn't know what he was doing. That's what I firmly believe, and until I know otherwise, I'm going to say that's what happened. I'm going to say that they had dirty fuel. The generator's frequency dropped so low that the switchboard opened, the circuit breakers opened. The generators were then able to run on zero load but maintain their speed. Duty engineer came down and just reconnected them to the switchboard, and of course as the fuel became starved again at the engines, that's when they suffered the second blackout, which led to absolute disaster where 6 people lost their lives, and of course the port of Baltimore was severely affected, and I do believe it's opened up now. There's at least 2 passages under the good side of the bridge still, so that's a good thing that trade was able to continue. Anyway, I've rambled on. I've probably gone over 10 minutes, so we'll try and edit it down a little bit further. Anyway, so that's about it then. I'll catch you all on the next one, and I'll see you on the next one. Goodbye.